All right, so you know those large language models everyone's talking about, the LLMs?
Yeah.
Well, you shared this paper with me, and it's
Okay.
about LLMs playing poker,
Yeah.
which I gotta say sounds like, I don't know, like something out of a sci-fi movie.
Yeah.
But knowing you,
Uh-huh.
there's got to be more to it than just like some AI trying to bluff its way to like a royal flush or something.
You know me too well.
Huh?
It's not just about poker.
Yeah.
It's about really kind of pushing the boundaries of like what these LLMs can actually do.
Okay.
This paper introduces something called PokerBench.
PokerBench.
Yeah. It's this new benchmark.
Okay.
And it's designed very specifically to test how well these models can handle all the the complexities of Texas Hold'em.
So, okay, before we like deal ourselves into all the details, can you give me the high level overview? Like, why is this research important,
Sure.
and what kind of like insights are we even talking about here?
Okay, so think about it this way. Games like chess and Go, where like all the information's right there out in the open, you know.
Right, yeah.
Those have been like conquered by AI for a while now, right?
Yeah.
But poker, that's a totally different beast.
Oh, yeah.
You've got hidden information, you've got bluffing, you have to read your opponent's behavior.
Right.
It's just as much about like psychology and strategy as it is about logic.
So PokerBench is like, they're trying to see if these LMs can finally crack the code
Exactly.
of this like more human-like game.
Exactly. And the results are, I gotta say, they're fascinating.
Okay.
Turns out some of the biggest names in LLMs, you know, like your GPT-4s and your chat GPTs, they weren't all that great at poker, like initially, you know, they really struggled to like consistently play optimally using all those like game theory principles.
Interesting.
But here's where it gets really interesting.
Okay.
When the researchers took a smaller LLM and they like fine-tuned it specifically on PokerBench data, it significantly improved.
Really?
It actually ended up surpassing GPT-4's performance on the benchmark.
Wait, hold on. You're telling me a smaller model, like a fine-tuned one, outplayed the giants?
Yeah.
That's kind of like a David and Goliath situation, isn't it?
It really is. But there's a twist.
Always a twist.
So they then pitted this like fine-tuned model, right, against GPT-4 head-to-head.
Oh.
And guess what?
What?
GPT-4 won.
What?
Even though it scored lower on that PokerBench test itself.
Okay, now I'm really intrigued. How did that even happen? Like, did GPT-4 like pull some kind of AI poker magic trick or something?
You could say that. It actually learned a strategy called donking.
Donking.
Donking. It involves betting out of turn.
Oh, okay.
And it's often considered a risky move.
Yeah.
But against the fine-tuned model, you know, which was playing this more by the book, you know, optimal strategy.
Right.
GPT-4's donking ended up being surprisingly effective.
So it wasn't even about playing perfectly.
Right.
It was about like finding and exploiting the opponent's weaknesses.
Exactly.
This is starting to feel less like a poker game and more like, I don't know, a lesson in AI psychology.
Exactly. It highlights this crucial insight into how LLMs learn.
Oh.
Sometimes it's not about, you know, rote memorization of like optimal strategies, but about adaptation, understanding context,
Right.
and even, you know, a bit of cunning, you could say.
Okay, you've definitely hooked me. Let's unpack this this PokerBench a bit more.
Sure.
What exactly does it consist of?
Okay.
And what makes it such a like valuable tool for, you know, evaluating LLM performance?
So PokerBench is this data set of over 11,000 very carefully curated poker scenarios.
11,000.
Yeah. And they cover a wide range of like pre-flop and post-flop situations.
Pre-flop.
Yeah.
Post-flop. Forgive me, but I'm not exactly a poker pro here.
No worries.
Can you like clarify what those terms even mean?
Sure. Pre-flop refers to the stage of the game before any of the community cards are dealt.
Okay.
And post-flop is after the first 3 community cards, they're called the flarp, have been revealed.
Got it.
So PokerBench includes scenarios from both of these stages.
Okay.
Which means that the LLMs, they have to make decisions with like varying levels of information available to them.
Got it. So it's not just about knowing the rules of poker.
Right.
It's about adapting your strategy.
Yeah.
Based on like the flow of the game and the information you have.
Yes.
Different points.
Precisely. And to make sure that these scenarios are like truly representative of high level play.
Yeah.
The researchers, they collaborated with like expert poker players.
Wow. Okay.
They even used, get this, existing game theory optimal GTO poker solvers.
Okay.
These are AI systems that have already like mastered poker.
Really?
Yeah, so they use those to double check the correct plays.
For each scenario.
So they've essentially created like a gold standard for poker play.
Yeah.
That these LLMs are being like tested against.
Exactly.
But you mentioned that this research goes beyond just like seeing if AI can win at cards.
What?
What's the bigger picture here?
So think about all the real world situations that involve strategic decision making.
Okay.
But with incomplete information, like negotiating contracts,
Right.
navigating financial markets, even things like diplomacy and military strategy.
Okay.
If LLMs can master these skills in the context of like poker, right? It could have huge implications for their application in like much broader domains.
That's fascinating. So this seemingly niche research is suddenly opening up all sorts of possibilities.
Right.
So we know that LLMs initially struggled with PokerBench, but then fine-tuning led to significant improvement.
Let's dive into those results a bit further.
Right.
What exactly did the fine-tuning process involve, and what were like the most significant findings?
So the fine-tuning process, right. They took a relatively smaller LLM, a Llama 3.8b model, and they trained it specifically on a subset of that PokerBench data.
So instead of feeding it like the entire fire hose of internet data, they gave it a concentrated dose of like high-level poker strategy.
Precisely. And the results were pretty impressive.
Okay.
This fine-tuned model, it shot up to about 80% accuracy.
The PokerBench.
Even surpassing like GPT-4, which had only managed, around 53%.
Okay, that makes sense. But I'm still kind of stuck on this fact that GPT-4 managed to beat this fine-tuned model in a head-to-head match.
Yeah.
How do we even reconcile those seemingly contradictory?
Yeah, right. It all boils down to like the different ways that these models are learning and what PokerBench is actually designed to measure.
Okay.
So PokerBench, it evaluates how well an LLM can play optimally based on like all those game theory principles.
Right.
But it doesn't necessarily capture all the nuances of, real gameplay.
So while the fine-tuned llama model was playing like by the book, GPT-4 with its massive data set and more generalized training stumbled upon a strategy that, while not always optimal, proved to be very effective against its opponent.
Exactly. Remember that that donk betting strategy we talked about?
Yeah.
That's what gave GPT-4 the edge.
Interesting.
It learned to exploit that fine-tuned model's tendency to play predictably. Even if those donk bets, weren't always the correct move according to,
game theory.
Game theory.
That's a fascinating insight.
Yeah.
So are we saying that sometimes being too focused on optimal play can actually be a disadvantage?
In a way, yes.
Okay.
It really highlights a blind spot in how we currently evaluate these systems.
Okay.
We tend to focus on benchmarks that measure adherence to optimal strategies. But real world scenarios are often much messier and less predictable.
That makes a lot of sense.
Yeah.
It's like the difference between studying a textbook and actually playing the game.
Oh, you did.
You might know all the rules.
Right.
But if you can't adapt to your opponent's moves, you're not going to win.
Precisely. And this has significant implications as LLMs move beyond just games and into, more complex real world applications.
Like those examples you mentioned earlier.
Yeah.
Contract negotiations, financial markets, even diplomacy.
Exactly. Imagine an LLM negotiating a business deal. Right.
If it's too rigid in its adherence to optimal strategies, it might miss opportunities to adapt to the other party's tactics or find, creative solutions.
It's almost as if we need to teach LLMs to be a little bit more street smart.
Yeah.
A little less by the book.
That's a great way to put it. And that's what makes this research so thought-provoking.
Yeah.
It's not just about creating AI that can win at poker.
Right.
It's about understanding how these systems learn, how they strategize, and how they interact with like the complexities of the real world, including, you know, other intelligent agents.
It's like we're peeking into the minds of these AI systems and getting a glimpse of their potential, both the brilliant and the slightly unnerving. Before we get too carried away with these philosophical musings,
let's shift gears to something a bit more lighthearted.
Yes, it's time for our novel notions segment.
Exactly.
Where we take inspiration from the research and you know, brainstorm some wild out there ideas.
Exactly. So with PokerBench in mind, what are some like potential research avenues or applications that this paper has kind of sparked for you?
Well, one idea that like immediately comes to mind is what if we develop an LLM that not only plays poker, you know, optimally, but also learns to identify and exploit the specific weaknesses of other LLMs.
So kind of like an AI poker coach?
That
could analyze your opponent's playing style and suggest like the perfect counter strategy.
Exactly.
That would be amazing.
Imagine having this AI kind of whispering in your ear. They tend to overestimate their hand strength after the flop. Time for a well-timed bluff.
Now, that would take the game to a whole new level.
But
beyond just poker, such a system could have like implications for other strategic interactions, right? Like negotiations or even cybersecurity.
Absolutely. Think about being able to like analyze the decision-making patterns of another AI system and predict like its vulnerabilities.
Yeah, that opens up some like exciting possibilities.
And it really does.
Okay, here's another thought. We saw how GPT-4's, you know, unconventional donking strategy kind of caught that the fine-tuned llama model off guard. What if we could develop a way to like measure how susceptible an LLM's poker strategy is to those kinds of exploits?
That's a brilliant idea. We could create like a sort of exploitability index for LLMs.
And this index could help us identify which LLMs are playing too rigidly, you know? Sticking to the textbook without considering the possibility of like, deception or unconventional tactics.
Precisely. And it would be so invaluable for like researchers and developers, allowing them to build, you know, more robust and adaptable AI systems.
So in a way, we'd be teaching LLMs not just to play by the rules. But also to understand when the rules might be like bent or broken.
Exactly. It's about moving beyond the limitations of purely optimal strategies. And embracing like the messiness and the unpredictability of, you know, real world scenarios.
This PokerBench research has really opened up some fascinating avenues for exploration. It feels like we're just scratching the surface of what LLMs can really achieve in, you know, strategic domains.
And the insights we gain from, you know, studying these systems in the context of games like poker could have like far-reaching implications for how we develop and deploy AI in the future.
It's a reminder that AI research isn't just about building like bigger and faster models. It's about understanding how those models think. How they learn and how they interact with the world around them.
Well said. And with that, I think it's time to wrap up our deep dive into the world of LLMs and poker.
To all our listeners, thank you for joining us on this journey.
Thanks for listening, everyone.
We hope you found it as insightful and thought-provoking as we did.
And don't forget to check the episode description for a link to the full PokerBench paper if you want to, you know, delve deeper into the research.
And until next time, keep those algorithms humming and those neurons firing.